Hello, BitFreak here, and in this video I want to attempt to give a brief overview of how the mini blockchain scheme works. In case you're unaware, the mini blockchain scheme is a new cryptocurrency scheme designed for maximum scalability, and Cryptonite is the first implementation of that scheme. You can find more information at cryptonite.info, and that's with a C, not a K. You can find the wiki by going to community and then wiki, or cryptonite.info/wiki. Because I'm only going to give a brief overview in this video, so if you want more technical details, go take a look at the wiki. I already made this video recently, but I rewatched it and I decided that it could have been a lot better, so I decided to remake it. It's pretty much going to be the same as last time, except hopefully just explained a little bit better and with a bit more detail. And start off the same way by refreshing our memory on a few things about the way Bitcoin works. So once again, I'm assuming most people already understand this basic Bitcoin blockchain thing, how that works. So you've got your chain of block headers. So this whole thing here is a block, and then your blocks link together, and this here is your Merkle hash tree, and in this case we've got 4 transactions at the bottom, and then the hashes all combined together all the way up to the root Merkle hash, which is stored in the block header. So every block header here would also have this same type of Merkle hash tree, and it would also have the root hash associated with that stored in the block header. So every block header here has a root hash in it, and a nonce and a timestamp and a few other things. And then this whole thing, the transactions along with the block header, represents a block. And then, as I said, the blocks link together to form the blockchain. So that's the basic blockchain concept. Now let's think about what happens when you want to make a transaction in Bitcoin. So the first thing you need to do is go back and find an unspent output. So you need to find a transaction where someone has sent coins to you. So in order to spend Bitcoins, you need to go back and find a transaction where someone has spent coins to you. And then you need to solve the script. So usually when the software will make the script for the user, but you can also manually write your own script. You could write all sorts of complicated scripts, and that's where the more complicated things like decentralized, autonomous corporations, and all that sort of thing starts to come into play. But the thing that I mainly wanted to point out here was that, well, first of all, that the transactions in some sense are the money, right? Because in order to spend coins, you've got to go back and find a transaction where someone else has sent you coins. And the transactions, they all link together. So that's the first point. The transactions in some sense are the money. The second point is that well, they all link together, as I just said, and that makes it extremely computationally expensive to download and validate the full blockchain. Because see, when a new node wants to join the network and it wants to become a full node, it has to download the full blockchain, and then it has to follow all those links to calculate the balance. It has to validate every single transaction in the blockchain and go through all the blocks all the way up to the current block height. And the blockchain is already over 20 gigabytes in size. If that wasn't bad enough, then they have to also validate all the transactions after they've downloaded it. Well, it's sort of simultaneous. As they download, they validate. But anyway, they're the 2 points I wanted to, 2 things I wanted to point out. So the first point is important because it means Bitcoin has no concept of balances, right? Because, as I said, the transactions act as the money in some sense, and so there is no, for example, I've drawn that really badly. Let me just use this. It's disappeared for some reason. So there is no balance sheet with Bitcoin. And so a typical balance sheet would look something like this, where you've got your um, an address and then some balance, say 1.1 coins or whatever currency, whatever you're denominating your currency in. So um, Bitcoin has no concept of this sort of balances. In order to calculate the balance, you've got to do what I said. You've got to follow the links, find the unspent outputs, and whatever. So this is a very, well, it's not a very scalable scheme, as might be obvious. Now, there are some um, ways that that blockchain bloating can be slightly remedied, not entirely remedied, but the effect of blockchain bloat can be minimized. And there are two main ways in Bitcoin how that can be done. And that is by pruning unspent outputs, which means, say for example, and I think this is described in the original Bitcoin white paper, say for example these two transactions here are spent, which means somebody else has used them as inputs in another transaction and they have spent these outputs here. So they're no longer really needed because you can combine this hash here and this hash here. You can combine these two node hashes here to get the root hash here at the top. So you don't necessarily need these two transactions as long as you have this hash here. So that is one way you can sort of free up disk space in Bitcoin, because there's no need to keep those spent outputs, because you're never going to need to go back and reference them because they've already been referenced somewhere else and you can't use them twice. Obviously, because then double spending would be possible if you could use them twice. So the main problem with this is that it still doesn't really completely eliminate the need for the full blockchain, because new nodes, when they come along, they still sort of need to download the full blockchain in every transaction so that they can go through it and make sure everything has happened as expected and they're not just getting some made up blockchain. So that's the main problem with that, and I think there are schemes like the ultimate blockchain pruning scheme. I think that possibly might extend on this idea and make it a bit more workable, but I'm really not sure of the exact details of that, and I don't think there's much progress going on in that area of Bitcoin development right now. So the other method used to reduce the impact of blockchain bloat is the use of light nodes. So there are some clients like Multibit, I think it is, which uses the light node protocol. So what that is, basically, it just has to download the block headers, so the header chain, and then it can, with only the header chain, it can still validate certain transactions. If it has the transaction, um, it can get all these hashes that it needs in order to validate the root hash, and then it can make sure that that matching root hash is stored in the block header, because the block headers have the proof of work in them. So you can still have a secure, safe header chain. You don't need the transactions to know that the header chain is secure. And so if you just want to validate like a single transaction, say this one here, all you would need is this transaction here so that you can calculate this hash here, and then you'd also need this hash here so that you can calculate the root Merkle hash. And I think that's roughly how it works. I'm not exactly sure. That basically is the idea, so that you don't need to download the full blockchain and all the transactions, because that's what the blockchain is. It is a history of every single um, transaction that has ever happened. And so obviously, as I said, this is not a very scalable scheme, this blockchain thing. And the Bitcoin blockchain is already over 20 gigabytes in size. Now the main problem with this light node idea is that light nodes are extremely limited in the things that they can do. Pretty much all they can do, I think, is like validate very specific transactions that they know about. Other than that, they can't mine and they can't really do anything else. They can't be a full node in the network. That's why they're called a light node. So how can we remedy this situation in a much more satisfying manner? How can we make it more scalable? And that is basically what the mini blockchain scheme tries to do, is maximize scalability of the blockchain so that it can last a long time into the future without, and you don't need to download a ridiculous amount of data in order to become a full node. And so that helps the network to remain much more decentralized when it's much easier for anyone to join the network and become a full node and participate and help the network stay strong and robust. So the mini blockchain scheme does have a balance sheet like this, and it does have a concept of address balances. So it's in many respects, it's much simpler than the original Bitcoin blockchain scheme. So it's not really that hard to understand, despite the fact a lot of people seem to have problems understanding it. And I think the main reason they have problems understanding it is because they are so familiar with the way Bitcoin works, and this concept is very much different in a very fundamental way. There aren't many altcoins that are so dramatically different on such a fundamental level. And hopefully this video will help you understand why that is. And so in the mini blockchain scheme, we've got what we call the account tree, and that is, if I can draw it neatly here, it is basically the same thing as this Merkle hash tree here. Well, in reality, it's a much more complicated structure. It's a type of radix trie structure, but I won't get into the details of that. As I said, you can go read the wiki to find out a bit more if you want to learn more on the exact technical details. But it's much easier just to think about it as sort of this Merkle hash tree structure, and that is how the very original mini blockchain scheme was designed. We didn't have the more complicated structure that we use now. So it's easier just to think about it this way, and it's easier to explain it using this structure. So you have basically the same thing as this Merkle hash tree, but at the bottom we have what we call accounts. Now these are not accounts in the normal Bitcoin sense, like an account that you might find in a Bitcoin wallet or any other wallet. That type of account is just a collection of addresses. Each account here only has one address associated with it. So for example, this account here has an address and it has a balance. And each account in the account tree has a similar thing. Has the address, the balance, and the withdrawal limit, and a few other things. And I'm not going to explain withdrawal limits in this video. I might, if I'm going well on time, I might give a brief explanation at the end, but I doubt it. Alright, so now let's think about... So well, basically what the account tree is, first of all I should explain, is this balance sheet here, this format, but we have transformed it into this sort of hash tree format. And at the bottom, each leaf node represents like a single entry in the balance sheet. So now let's think about what should happen when we make a transaction within the mini blockchain scheme. So the first thing that someone will do when they want to make a transaction is all they need is the address that they want to send to, um, the address that they are sending from, and they need the private key associated with the address that they are sending from, so that they can sign the transaction and validate that they have authority to send coins out of the address that they are sending from. But all they need as the output is the recipient address. They don't need to go back and find any unspent outputs. They don't need to go back and reference any other transactions or solve any scripts. All they need is the address of the person they want to send to. So you can have multiple outputs and multiple inputs in the mini blockchain scheme, but each input is just an address and each output is just an address. But for every input there needs to be a signature which authorizes coins to be sent out of the input address. I'm not going to explain exactly how the signature signing stuff works. I think there's fairly good details of that in the wiki. So basically what they will do is they will make the transaction with the input address, the output address, then they will sign it with the private key associated with the input address, then they will broadcast the transaction. When miners receive that transaction, they will then put it into the block that they are currently mining. So mining works essentially the same way as normal Bitcoin mining works, except the difference here is that when the miner receives the transaction, he will apply it to the account tree. So say for example that the transaction has an input, the input of the transaction points to this account here. And I might use the terms account and address interchangeably because as I mentioned there is only one address associated with each account in the tree. So say this is the address the coins are coming from, the input address, and the output of the transaction is sending coins to this address here. Now when the miner receives that transaction, he will subtract the appropriate amount of coins from this address and then add them to the balance of this address or this account. So subtract from the balance of this account and add to the balance of this account, and then he will recalculate all the hashes. So this hash all the way up to the what we call the master hash. It's basically just like the root hash. And inside the block header is that master hash value, and so the miner will update the master hash saved inside the block header. So every time a new transaction is put into the block, the miner will have to update the master hash. And so then when the miner finally solves that block and then broadcasts the solved block, one thing I should mention quickly first, before the miner will even accept the block, he will validate the signature and make sure the signature matches the input address. But back to where I was, when the miner broadcasts the block, and then other nodes receive that block, they will do what the miner did when he applied that transaction to the account tree, but they'll do it for every single transaction in the block. So they will go through every transaction in the block and apply it to the account tree. And then finally, what they should end up with is the same master hash. Their account tree should end up having the same master hash that is in the block they just received, that is in the block header. So the master hash in the block header should match the master hash they get after applying all the transactions in the block. And then that is how every node in the network can be certain that they have the exact same copy of the account tree. And that is sort of how it's cryptographically secured. You can already sort of start to understand why this would be hard to forge a copy of the account tree. But once again, I'm not going to go into all the technical details of all the security details. But moving on, yeah, so the important things that I want to highlight about that whole process is mainly one, that you don't need to go back and find any old transactions. So in some sense, transactions become spent instantly after they are applied to the account tree, because once you've applied them to the account tree and you've updated the balances, you know what the balances are and you never need to go back and check that transaction ever again. So all transactions in the mini blockchain scheme instantly become spent once they are applied to the account tree. So one last thing I should mention about mining and how that works is that this first account here is actually what we call the Coinbase account. So in the Genesis block, you'll notice that there's a weird transaction which sends the total coin supply to this account here. And that is because every single block reward is funded from this account here. So the input of a block reward is this the address of this account, of the Coinbase account. So that is why initially the total coin supply gets sent to this account here. So you can calculate, you can check easily how many coins are left to mine just by checking the balance of the Coinbase account. And you can provably destroy coins by sending them back to the Coinbase account, and that's one interesting thing worth noting. And you'll notice that that's very different from 99% of other altcoins. They have the Coinbase transactions in other altcoins have no inputs. They aren't the coins aren't sourced from anywhere. The coins are just sort of minted on the spot when they are mined. But it's completely different here because since we have a concept of balances, we can have an input for Coinbase transactions. Oh, the other important point, I said there are a few important points about the way transactions work. The first one was you don't have to go back and find any unspent outputs, so they don't link together. And in some sense that means they become instantly spent. So that means transactions can be forgotten rather quickly. All transactions, not because we don't have any concept of spent and unspent. We can, after transactions become old enough, we can forget about every single transaction once it's old enough. So every block header here would really have a Merkle hash tree associated with it. But at some point, once it gets old enough, there is no longer to keep this list of transactions, and so we can discard them. So if you download Cryptonite right now, you'll notice it only downloads the last 10,000 blocks. Um, so that is the last week's worth of transactions, because it's one block every minute, which is roughly 10,000 blocks per week. So all of these old Cryptonite transactions don't need to be stored forever. The network only needs to keep track of the last week's worth of transactions, and you can instantly see why this is extremely, um, very much more scalable than a typical um, blockchain scheme. And it's all down to the fact that we have this concept of balances, and because our transactions become instantly spent. And so when a new node synchronizes with the Cryptonite network, all it needs to get is this header chain. And if you read the original Bitcoin white paper, Satoshi explains that the header chain is extremely small. The transactions make up the largest part of the blockchain. The headers just by themselves, they only grow at a rate of, I think it's a couple of megabytes per year. Um, and that's just the header chain without the transactions, and it's extremely small. And so in Cryptonite, um, it's very quick to download the header chain, and then all they need to download apart from the header chain is the transactions associated with the last 10,000 blocks. And also the account tree. But with just those three things, just with the header chain and the last 10,000 blocks worth of transactions and the account tree, they can become a full node in the network. They can mine, they can do anything else a full node can do. Um, and one of the important things I forgot to mention about the transactions is if it is sending to an address which does not exist in this account, the address will be inserted as a new leaf node in the account tree. So if the address doesn't exist in the account tree, it will be inserted as a new leaf node. And if an address becomes empty, so if all the coins are sent out of an address and the balance becomes 0, then the leaf node will be removed from the account tree. And so that just ensures it stays as small as possible. But obviously over time, as new addresses get inserted into this account tree, it's going to grow over time, and so eventually this will probably end up being the largest part of the entire scheme. But right now it's extremely small. It's like 130 something kilobytes in size or something, very, very tiny, which it's quite small considering the amount of addresses that already exist. So this is basically just like, it's like a balance sheet, a list of every single non-empty address in the network. That's basically what it is. And compared to the Bitcoin blockchain, which is a list of every single transaction that has ever happened in history, you can see why it's much more scalable compared to the original blockchain scheme. Um, so, and the other important thing to realize about transactions is that they don't use scripts, which I probably should have mentioned much earlier, which you probably already realized that. Is obviously because the inputs and outputs are just addresses, they're not scripts. We only have a limited predefined set of transaction types. So you've just got that type where I explained where you can send coins from one address to another, and you can have multiple inputs and multiple outputs. We do also support multi-signature transactions. That's another type of transaction. And then there's also a special type of transaction which allows you to update your withdrawal limit associated with your account. As I said, I won't get into that. And so you basically got those main three types of transactions. And so basically what this allows is maximum scalability because, um, well, it only allows a predefined set of transaction types and not any type of script transaction. Now you might think that that is um, sort of a major factor, something you'd really want. But when you think about Bitcoin, there's only a very limited standard set of transaction types that you can do anyway. Um, if you want to make a non-standard transaction, it's extremely hard to get it accepted into a block and to get it propagated. Um, and there's a lot of effort underway now to make it even harder because they want to make it harder to help prevent transaction malleability. And in Cryptonite, we actually have completely eliminated transaction malleability because we do not use scripts. Um, and because of the way we hash the transaction to get the transaction ID. Um, so we have completely eliminated transaction malleability um, within Cryptonite. Um, so the important thing that I want to point out about that is, well, first of all, as I said, we only have a limited set of transactions, um, but it's not really that bad because Bitcoin in reality has a limited set of transactions. And people really only want basic banking functionality. Not many people really want to write complicated scripts and do more complicated things. They just want to be able to send coins from address A to address B, maybe make a multi-signature transaction. Um, but beyond that, there's not much they really do. They really want to do. Um, but obviously, there are uses for scripting, and I'm sure that the new coins like Ethereum, or however you pronounce it, the new coin that's supposed to have full Turing complete scripting, I'm sure that those coins will produce very interesting things. I'm sure interesting things will come from that. Um, but the mini blockchain scheme is mainly just an effort to give people basic banking functions in order to produce maximum scalability. Um, and the other thing to realize about not using scripts is that it makes transactions much smaller. Because scripts can be very long and complicated, and when the inputs and outputs are just addresses and coin values, then it's much smaller, and you get a lot more bang for your buck. Each block can fit more transactions inside. And then also we can forget about old transactions. Um, so it's extremely quick. Even many years from now, if you download Cryptonite and you download the blockchain, you will notice it only downloads the last 10,000 blocks, and it's in a decade from now, every single other altcoin is going to have a ridiculously huge blockchain, and only the mini blockchain altcoins will be um, reasonable size. And they will be the only coins most people will be willing to attempt to even synchronize with the network. And so the main idea is that it should last long into the future without getting bogged down by blockchain bloat. Um, and that's why with Bitcoin now, the maximum block size is 1 or 2 megabytes. Um, and each block can be no larger than that maximum block size. And so the limit, the cap is in Bitcoin, the cap is 7 transactions per second. It cannot get faster than that without increasing the maximum block size. In Cryptonite, it's actually we have a dynamic maximum block size. I think we're actually the first altcoin to have a dynamic maximum block size. I think it's 2 times the average size of the last 100 blocks. So the maximum block size will grow over time as the transaction rate increases. It'll naturally grow without having to implement any hard forks in order to increase the maximum block size. Um, and we can handle that due to the fact we don't really have to worry about blockchain bloat, because we only need to keep track of the last week's worth of transactions. Now obviously the size of the last week's worth of transactions, the size of those 10,000 blocks will grow over time as you get more transactions in every block, or whatever else. So there are a few aspects, like I said, the account tree and a few other things that might grow over time, but it's still obviously going to be much, much more scalable than any other blockchain scheme in existence. Um, and you can see why it's fundamentally different. Um, Hopefully what I've explained has made it very clear. A lot of people ask me, how can I convert my altcoin to support the mini blockchain scheme? Um, but as you might have guessed by now, it's not really possible because we don't use scripts, the transactions don't link together, and we're very different in a very fundamental way. So unfortunately, you can't really convert any existing blockchain schemes into a mini blockchain scheme. And that's the reason why I had to create a whole new cryptocurrency called Cryptonite. Um, Otherwise, I probably would have just attempted to help make Bitcoin more scalable. But this idea really needs a whole new coin to make it work properly. Um, I think that does pretty much wrap it up now. So thank you for watching. I will see you next time.